Okay, we are going to finish up this last problem in the 4-7 notes. And we are practicing taking an equation in standard form and then rewriting it in vertex form. Okay, and this is what you're going to do. This is your worksheet. You're going to follow these steps. They're all given to you in standard form, and you're going to rewrite it in vertex form and then graph from there. So let me just review over quick the steps. So the first thing you do is kind of like group the x terms together. So that's why I have the parentheses around the x terms. Then you have to make sure that the a value or the number in front of x squared is a 1. So we did one where it was already a 1, and then in this case it was not. So we had to factor out that -3, which gave me x squared plus 6x left, and then we left kind of that plus 10 outside. Then we complete the square. So you take half of b, which is 3. 3 squared is 9. We want to add 9 inside that group to make it a perfect square trinomial, because then that green piece, what I underlined, would factor into x plus 3 squared. Now, you can't just add 9 to one side of an equation. You got to counterbalance it, and we didn't even really add 9. We technically added -27, okay? So if I added -27, I had to add +27 to counterbalance this. That's how you put it into vertex form. I have a couple more on the next set of notes as warm-ups to practice this, and you'll get lots of practice in your homework. So let's review over how we graph then from here. The reason why we like this vertex form is I can pull my vertex from here. It's the opposite of this number, -3, and this number, 37, because it relates to my shift left and shift up. So that's the first thing we look for is the vertex. The second thing we look for is the axis of symmetry, which is that vertical line that goes right through the x value vertex, so just be x equals -3. You don't have to draw in your axis of symmetry. You can if you want to, if it helps you, but I don't require that. And then the third thing we find, anyone remember?
The x-intercepts.
Yes, the x-intercepts. Good. Thank you. Mm-hmm. The x-intercepts, which is when y is 0. So we just plug 0 in to our vertex form. And another reason why this is a nice method to graph in vertex form, A, we can pull our vertex, and B, it's really easy to solve for our x-intercepts. Because if we would have kept it in standard form, folks, we would have kept it in this form and plugged in 0, we would have had to use quadratic formula because it doesn't factor. And now this is kind of already the cleaning the square process is done for us. Okay, so we move over that 37. What would I do next? Divide by -3, so I get 37 thirds. Then I would square root both sides. Don't forget plus or minus. Okay, I'm going to move this on this side. I like to look at it this way. So you get x plus 3 is plus or minus the square root of 37 thirds. All right, I'm going to kind of simplify that over here. 37 over 3. That fraction obviously doesn't reduce. I square at the top, square at the bottom. I have to rationalize this. End up getting the square root. 37 times 3 is 111. All over the square root of 9, which is 3. Don't forget plus or minus. So then my x-intercepts end up being -3, subtract that 3 over, plus or minus the square root, 101 over 3. Ew, talk about some nasty numbers. Okay, now, I don't know about you guys, but when I look at that number in exact form, I'm like, how do I plot that? How do I plot -3 plus or minus the square root of 111 divided by 3? So we'll get decimals. Now, I want you to leave your answer exact, but practice getting decimals so you know how to plot this, okay? So let me show you how you type this in your calculator. Oh, good, my dot cam's on. First, I would just do the square root of 111 and divide that by 3.
Dude. In the practice. Right. Square root of 111.
Okay. So it's kind of dark.
Leave the lights off.
Yeah, he flipped that one. I don't remember.
That
Yes, there we go.
one.
Okay. So I would do the square root of 111, close that, hit enter, divide that by 3. So there's the irrational piece, the square root of 11 over 3. So I want to do -3 plus that number. So you're going to hit second answer, and it'll feed that decimal down there. Okay, answer's right over here. And there's 1 decimal. I did -3 plus that. Obviously, we have to do plus or minus. I always do plus first, just because that's written on top. Okay, I'm going to do it one more time because I'm going to do minus. So I got about, when I did -3 plus that irrational number, I got 0.5118 ... Okay, I'll show you guys that one more time. Now with minus, even though you could just go back up here and change it to minus and get that number, but I'll show you one more time. See, square root 111, close that. You can divide it by 3. You can do that all in one step as long as you close that. So we're going to get this very long decimal. And now this time I want to do -3 minus that number. So if you hit second answer, which is right above the negative symbol, it'll feed that down. Feed that entire, and you're not rounding or anything. So we get that. Okay, and like I showed you, if you're like, okay, so I just did the minus version, now I want to do the plus, you can hit the up arrow, just change it to a plus. There's not the right answer.
Because I used the answer from the previous one.
Yeah.
Oh,
You have to do it again. It's annoying. But it's
oh, got it. Okay. So that -6.5118, ... Okay, so to be clear, we do want to write our x-intercepts like this. But to help you actually graph it, get the decimals, because now I'm like, oh, about 0.5, that would be right here. That's easy to plot. And about -6.5, that'd be right here. 1, 2, 3, 4, 5, 6, halfway between -6 and -7. Now I do need to plot my vertex of -337, so I'm going to have to change the scale here on my y-axis. I just counted up by 5s, 10, 15, 20, 25, 30, 35, 40, 45, 50. And remember, your vertex should always be about like halfway between your x-intercepts. So when I go to put my vertex at -3, I'm like, hey, that does look like it's about halfway between my x-intercepts, right? Because those are like symmetry points. And then that's all you have to plot, folks. And you just plot the vertex, -3, about 37, about there. And then you have 1 point to the left of your vertex, 1 point to the right, so that's enough to draw in our parabola. Does it make sense that I got a sad face?
Yeah.
Yeah, look at my original equation, right? -3 leading coefficient. Now, I did change the scaling, but this is actually pretty skinny, right? Because it's -3, really like 37. So this would have been like really tall and skinny, and that's because we have that 3 out in front. Okay, that's what we needed to finish up in the 4-7 notes. So you'll see, let me just pull up Google Classroom quick. You'll see on like your homework the steps I want you to follow. Okay, so this is that worksheet I passed out yesterday.
Whoa, that's a lot of work.
So these, you'll see the directions say, complete the square to rewrite this in vertex form. Obviously, I didn't like show my work because that's what I want you to do, but I gave you what you should get in vertex form. Okay, that's what you should get. Then identify the vertex, axis of symmetry, and the x-intercepts. Again, I didn't show my work for that, but I gave you the end answers you should get. If you ever get irrational x-intercepts, I gave you the decimals too to kind of show you, all right, that makes sense. And then, folks, another like additional point you can do, I probably should have pointed this out here, but remember in standard form how you're given the y-intercept? You could plot that point too. So mine should have crossed at about 10 there. Okay, so like on this one, I just noticed it. I saw, hey, my x-intercept or my y-intercept is 3. You can plot that point too if you want. But really, all you need to find is the vertex by putting it in vertex form, the x-intercepts, and you have your parabola. Now remember, if you don't have any x-intercepts, where you get like imaginary solutions, something like this one, you're gonna have to find a helper point. So in that case, I just use the y-intercept. I was like, hey, the y-intercept's 9. There's my helper point. Okay. If you recognize that this is u up and my vertex is way up here in quadrant 1, and it's u up, you don't have to go through all the work of like showing the x-intercepts and getting imaginary solutions. You can just recognize that none, it's u up. Or if you recognize, oh, my vertex is on the x-intercept, so that's going to be my only x-intercept. Save yourself some math by recognizing and like making those connections. Okay. So I have 2 good things to tell you. First, we're going to do notes today and tomorrow. Friday's a work day. And if this motivates you a little bit, this is literally today and tomorrow's lesson is the last one we have to learn before Christmas.
Really?
Why don't you tell me the other
Yeah.
thing about
Wait,
it?
we have how is that possible?
5 pages.
Because we have the test and then
So we
the
have one
break
more
and then
quiz
the
to do.
exam.
We got one more quiz, which is Monday.
Yeah.
One more quiz.
Project.
Woo! We have a chapter 4 test, which I'll give you a couple of reviews. I think I tentatively have it scheduled for next Thursday, because there's one day that seniors are going to be gone next week, I think.
James.
So I think I have it scheduled for
Oh, I think that
Thursday.
trip got canceled.
What?
Oh, really?
There's Miss Carlson this thing too.
Oh. You know what the field trip's for?
I think it was to see a play. Right?
Yeah, was that
Oh, okay.
isn't that?
Oh, wow.
I'm going to stop this recording and start a new one with 4.8 so I can put it under that topic in Google.
College prep.
Yeah, sir. So what's the catch?
What do you need college
What do we do
prep
after
for?
the test then?
We're
Yeah.
doing,
She's not on. I'm